problem. So the question, like right now for COVID, is how do we deal with that virus and how do we make a vaccine for it? The other thing they do is then they do their research. So that would be step number 2. And that we already know a little bit about COVID, but we're going to do more research from the people that are getting sick with it and that kind of thing. Then you do a hypothesis. And the hypothesis is, if I do this, this will happen. And I want you guys to think about that as we go through these experiments. Then we do the experiment to see what will happen. Then we do our observations, so we watch and see what happens. Then we do our results, and then we actually write it up, or we do a report or whatever. And that's the scientific method, okay? So the first one we're going to do today, because this is going to have to sit for an hour after we get it all set up. So we're going to start with it first. So everybody needs to, on your supply list, the very first thing that was there was the bowl, your chocolate, your milk, your cream, ice, and salt. Okay? So everybody go ahead and get your supplies together. Oh, and I forgot the glass, so you can have something to put it in. Okay? You guys got your supplies? You ready for me? Okay. You need something to put it in. So I'm using this glass, okay? It can just be anything, whatever you're going to do. And so the first thing you're going to do, and I'm using a tablespoon, okay? So you can use any kind of a measure you want to, because we're not going to do it by amounts, we're going to do it by numbers, okay? So I'm just using a tablespoon. So you need 1 spoonful of your chocolate mix. And put it in your glass or cup or whatever you're using. You need 2 spoonfuls of milk. Okay, so 1 spoonful of chocolate, 2 spoonfuls of milk. And then you need 1 spoonful of cream. Now, you can use half and half or whipping cream, whichever one you got. I'm going to use half and half.
So what do we have to form? 1 spoonful.
1 spoonful of chocolate, 2 spoonfuls of milk, and 1 spoonful of cream. Okay, and you can stir that up, mix it up. Okay, in your bowl now we're going to put some ice. Not a lot, just cover the bottom of the bowl. Okay, kind of like this. Can everybody see?
Okay, we have Sawyer has a question.
Okay. Go ahead, Sawyer, unmute your mic and ask me your question.
Hey, Miss Starla, we got lost with the chocolate milk mix stuff. Could you redo that?
You ready? 1
Yep.
chocolate mix, 2 milk, and 1 cream.
It's in the chat box too.
It's also in the chat box. Miss Nikki's working with me today and she put it in the chat box.
Click on here. What?
Only two.
Yeah.
One milk,
Click on that.
two chocolate, 2 milks, 1 cream.
Okay, 1 spoonful of chocolate, 2 spoonfuls of
Milk,
There's a lot of things. Good job, guys.
how y'all doing? Everybody doing okay? Oh, I love the thumbs up, thank you. Everybody got ice in their bowl?
We're doing good. We're doing good. Yeah, we're finished with steps so far.
Okay, good.
You are frozen.
And upside down.
Okay, so now we just need to put salt on our ice. So I put a couple of handfuls. Did you see that? I put handfuls on mine. And then we're going to sit your glass on the ice. Okay? Try to make it level so that your glass doesn't fall over. Okay? Then we're going to take and put more ice around your glass. So we're going to build up layers of ice around our glass. How are we doing? And then we're going to add more salt. Don't get it in your drink. And then that's whenever you're going to cover it with a dish towel. How are we doing?
But they're still working on it.
Okay, y'all keep working because we're going to talk about this a little bit. We're doing hot and colds. So when something's hot, it gives off heat and it's a hot drink like tea or cocoa or coffee like your mom and dad drink. And whenever something's cold, that's different. It feels different. And that would be something like ice cream. But both of the sensations are caused by something called heat. Ah, that doesn't sound like it should be like that, huh? The difference is that the cold objects contain less heat than the hot objects do. And our bodies make heat from eating food, and then we get warmth from the sun. So we've actually mixed all of our mix in our glass, and we put it under the dish towel. Why do you think we put salt on the ice? Who knows? Kara, go ahead and unmute your mic.
To make the ice super cold.
Okay, actually salt melts the ice, but then what it does is it also makes it colder. So she was right. So why did we cover the bowl with the dish towel? Jaegers? Go ahead. Unmute your mic.
Keep the cold in.
Okay, she said to keep the cold in. Actually, the reason we did it is to keep the heat from the room from getting into our bowl, okay? And so then what is the ice drawing the heat from? Kara?
The salt.
It's no. Think about it. What's it drawing the heat from?
Our milk and cream.
What do we
Milk
put
and
in the
cream.
bowl? It's drawing the heat from your milk, from your mixture. So then what's it going to do to that mixture? If it's drawing all the heat out, it's going to turn to what? Jaegers?
Gonna freeze it.
It turned to ice, right? It's going to freeze it. So that's the reason we did that, okay? So now we know that ice needs heat to melt, and it takes it from the ice, from what we have in the bowl, the ice cream mixture, and it makes it so cold it freezes it, okay? So now we're going to leave that sit because that's going to have to sit for a little while in order for the ice cream to make. So that was the reason we started with that. All right? So the next one we're going to do is you guys will need your fork, your book.
Come back.
You'll need your fork, your tape, your book, okay, and your wire. Because this one's going to have to sit for a while too. Okay, on your fork, you need to put a little sheet of tin foil. Okay, just one piece. Put it on your fork. Okay, and that's to hold your ice cube. I just folded it around my fork. So little tiny square like this.
They need to put the fork under the book, right?
Yes, tape the fork to the table. Okay. Take the fork to the table, and we're putting a book on it just for make sure that it stays on the table. Okay, everybody got it?
No, the Jaegers do not.
I got a question, Jaegers? Okay,
They're trying to get it set up.
I think he's going to. So. Okay, I want everybody to watch me because this is gonna take you a little while to do. You take your wire and mine's real thin, it's gonna be hard to see. You take your wire and make a loop, and then I looped it around the top of the bottle so that it can be suspended, so that I can hold it, okay? So you need to be able to wrap the wire around the head of the bottle, but also then you need to be able to have a loop of wire. Okay? I put an ice cube on my fork. Here's my ice cube. I put it on my fork. And you guys, Mom, they may need something under it because it will melt. And then you're going to loop the wire over the ice cube. Yeah, just a shake.
Focus it.
Keep it steady. Take this one in.
It's not focusing. Is there a way to turn the camera to focus?
Miss Starla, I think there you go.
We loop the wire over the ice cube, and then we're just letting it hang there.
That's good.
What do you guys think is going to happen to that ice cube?
No, point it at Starla. Let's see how it feels. There we go.
Huh? Anybody got a guess? What's fixing to happen to that ice cube? Jaegers?
The ice cube's gonna melt and the water's gonna drip down the wire and into the bottle.
Okay, the ice cube will melt, and the wire is applying pressure to that ice cube. But as the ice cube melts, remember that it's still cold, so the ice cube is going to freeze back. So the wire is actually going to pass through your ice cube and slice it, and then it's going to freeze back. And that's going to be something that you guys are going to have to watch on your end. Actually, mine's about halfway through already. It's kind of a neat trick to do. Now, I will tell you that it depends on the weight, how much weight you have. So whether you have a bigger bottle, like a 2-liter bottle, versus a small water bottle. So the weight that you have on that ice cube, on that wire. It also depends on the gauge or the thickness of your wire. The thinner the wire, the faster it happens and the more visible it is, the more that you can see. Okay, how's everybody doing? Okay. Does everybody have that one set up or not yet?
Not yet.
Okie doke. Do I need to repeat anything for anybody? How's everybody doing? What's the matter, Matilda?
We don't have it ready yet.
Okay. Put your foil on your fork. Take the fork to the table and put the book on the fork just to weight it down. You put your ice cube on the fork. Be sure then to put your wire in a loop and then loop the wire around the head of the bottle. And then put your wire on your ice cube. So Sawyer, you and Carol have it? Okay. Juliet, Wyatt, Joy, and Larry, you've got it?
This is too hard for us. We are just not doing it. We just want.
Okay, that's fine. Jaegers, you got it? Okay. What about Eleanor? Is it Mikey, William? Okay. All right. Now how we doing, Nathan? Nathan's dad's got it going on. Thank you, Nathan's dad. Okay, we're gonna let that one sit there for a while, but don't forget to keep watching it. Okay?
No.
Okay, so now we're going to move on. So now you're going to need your bowl, your candle, okay, your baking soda, and your vinegar. And then your match or your lighter, whatever you're using to light with. So we're going to sprinkle our baking soda. Now we're still on what I call hot and cold, okay?
I think they're still trying to gather all the materials. So they have a bowl with the candle and baking soda, correct? Trying to put instruction in there to go.
I knew what you were doing. Really appreciate it. You're just too good. Okay, you need your bowl, your candle. You need the candle secured somehow in the bottom of the bowl. Now make sure your candle is not taller than the top of your bowl. It needs to be in the bowl. And then all I did was I sprinkled some baking soda around the outside of my candle. Not on it, but in the bowl on the outside. We there? Candle in the bowl and baking soda around the candle in the bowl. Okay, you might need mom's help or Nathan, in your case, Dad. We're gonna light our candle. Okay. Light your candle. Be careful, don't burn the house down. Okay, everybody got their candle lit? No? Jaegers, you got a problem?
They're still gathering materials. There we go.
Okay. All right, my question for you is, what's making the candle burn? What is the candle using to burn? Jaegers?
Oxygen.
Very good. The candle is using oxygen to burn, okay? So now, everybody got their vinegar? We're gonna put vinegar around the outside of the bowl in the baking soda. Be careful and don't, it's gonna froth on you. Be careful and don't let it overflow and flow into your candle.
Use a spoon.
I'm using a spoon. What did your candle do? What did the candle do? The Jaegers?
It went out.
It did what? Say it again, sweetie.
It went out.
It went out. Who knows why it went out? Yes, ma'am? Jaegers?
Because the vinegar made carbon dioxide and it robbed the candle of its oxygen.
Very good. The vinegar and the bicarbonate of soda, or the sodium bicarbonate, it created carbon dioxide and it robbed the candle of oxygen. So it could no longer burn. It needs oxygen to burn. So it's kind of interesting that we realize what we can do with fire and other things and what the fire needs in order to keep going. Okay? How are we doing so far? Good? Okay.
Check on the ice cube.
Oh, the ice cube.
Oh, have y'all looked at your ice cube lately? What's your ice cube doing? Is it cutting through your ice cube? Yeah. Okay. Now, the other thing I need for you to do is I need for you to stir your ice cream. Why did we stir our ice cream?
Oh,
Who knows why we stirred the ice cream? Yes, Slayer?
To disperse the cold around so it
Very
all
good.
freezes.
That's it. We want all the molecules in there to get cold. Okay? All right. So now what we're going to do is we're going to move on to the section that we call air and gas. And we need the other candle or whatever you're doing. We need the candle again. And I'm going to use the same one, okay, that I used on the last experiment. I'm going to use the same one. And then you need something, a jar. I'm going to use a jar to cover it with. And you need colored water. And you need your match or your light or whatever it is that you were using. Okay? Okay. So what's all around you right now? What's always all around us? Julia, Wyatt, Joy, and Larry?
Oxygen. Oxygen.
Air. Okay? Air is around us all the time. Oxygen is a component of that. Okay? So that's around us all the time. We're hardly aware of it. We can't see it. We can sometimes feel it. When do we feel it? Jaegers?
When it's moving and there's like windy, breeze and like.
moving.
When does it move?
When there's wind,
Very good. We feel it whenever the wind is blowing. So that's whenever we know it's there. We breathe it all the time. What does it do for you? You don't have it, what's going to happen? Very good, Nathan. Nathan said we won't be here anymore. It provides you with life. Okay? So what else uses the oxygen?
Rachel says we can.
What else uses oxygen?
Well, that one.
Well, that one's got a microphone on it, so you just want to point it toward her. So
Oh, I can move right here.
What else uses oxygen?
plants, he said.
Okay, somebody said plants. What else? Jaegers?
Animals.
Animals, very good. So oxygen is really important for all of us, or air is really important for all of us, okay? Now, it also is needed, as we learned in the last experiment, it's needed to burn fuel too. If we didn't have it, we wouldn't be able to have a fireplace or something like that. It wouldn't work. Aircrafts use it to fly, so we need the air, so some machines have it. Those of you that were on the farm equipment one saw the helicopter needed it, so it's very important to us, okay? And so now what we're going to do is just see what happens with the air. So I have my candle. I have my candle in my bowl. Now I'm going to pour the water in the bowl. Do not let it go over the top of your candle. Okay? So just a little bit of water in the bowl. Okay? And now we're going to light the candle. Okay? And we all know the candle burns because of oxygen. Okay? So in my jar, what's in my jar? Oxygen or air. Okay? So now, did we all get our candles lit? Matilda, are you doing okay? Okay. Kara and Sawyer, are you doing good? Okie dokie. Okay, so my candle is in my bowl and it's still burning. Now what I'm going to do, are you guys ready? We're going to turn our jar upside down over the candle. Okay? And then I want you to look and see what happens. Watch yours and see what happens. What happened to your candle? Jaegers?
It went out.
It went out. What happened to the colored water?
Sifted in.
Jaegers?
It went in the jar.
It went in the jar. Okay, first of all, why did the candle go out?
Because it used all the oxygen.
Very good, Nathan. It's because it used all the air that was in the jar. Okay? It had no more air or oxygen to burn. Okay? Now, why did the colored water come up in the jar? Whenever it burned all the oxygen out of the jar, it left space in the jar. So the water came up in the jar to replace what space was left from the oxygen. And so that's the reason it came up in the jar. Does that make sense? Okay.
Cool, they said.
My wire is almost through my ice. another one. This is kind of a magic trick. But we're going to talk about why it works. You're going to need your glass, your cardboard that'll cover your glass, and water to put in the glass.
Used to be.
All right, put your water in your glass. And then you need a card that'll cover the top of the glass completely. And I'm using a plastic glass. It's not a real one, but you can use a real one. This is just what I had. Oh, I'm sorry, and Kara are using colored water. Cool.
Only might want to do it over a sink or a tub.
Yeah, you might want to do it over a tub. That's the reason I put my tub down here. Or sink, or a bowl. You don't want to have your cup of water all over the floor. Yeah, anything will work. Just something to catch the water just in case it spills. Okay, so you're going to put your card over your glass and make sure that it's touches all the edges. And then we're going to turn it upside down. And then you can take your hand away. And mine's not going to work. I can feel it already. There we go. Then you can take your hand away. No, you can't set it down. You gotta keep your hand under it and hold it up. Did anybody have any luck? Oh, we're going to try it again. Ah, there you go, Julia White, Joy and Larry. Nathan, how are you doing? Whoops. It finally gave way. Very good, Sawyer. Very good, Nathan. Jaegers, how are you doing? I'm good, Julia. Okay, Jaegers said they're doing good. All right, who can tell me why this is working? Who can tell me what's keeping the cardboard where it is and why the water's staying in the cup? Jaegers?
The air and water can't mix.
Yeah, I didn't understand
She
you.
said air and water can't mix.
Oh, she said air and water can't mix. That's not quite true. It's all deals with air pressure. The pressure on the outside of the glass is stronger than the pressure on the inside of the glass, and that's what keeps the cardboard up there. It's air pressure. And so that's just something that we have to start learning about and studying about, is to learn about air pressures. So the air pressure forces the card upwards, and air pressure is on us all the time. It's very strong, and it it can push against the weight of the water. If it stops pushing like mine did, mine finally gave way. My gut reaction is my card probably got soggy and it worked a little bit. As long as the card seals all the entire edge of the glass, as long as the card seals the entire edge of the glass, it's going to stay secure. Okay? All right, what do you think about that one? What they say?
I was just watching Nathan. Nathan got splashed in the face.
That's kind of what happened to me. That's what happened to me, Nathan.
I think they like that one.
Oh, okay. I have a helper here, and if Miss Nikki's here, but also my 4-H secretary is helping me today. And the next one we're going to do is one of her favorites.
Hey, Miss Starla,
I practice these together. Yes.
when you're standing right there, we can hear you better. I'm not sure if it's your microphone, but when you go to your right, it kind of makes it hard to hear you.
Okay, thanks. I can talk louder, Rachel. Okay, so the next thing you need are your balloons, more baking soda and vinegar, and your bottle, your long neck bottle or whatever you're using. I'm just using these little Coke bottles. These are those little mini Coke bottles. That's what I'm using. Okay?
Yeah, I wonder. It didn't come through. I don't think so.
Okay, I don't know if you can see it or not, but this is my ice cube. And my bottle is still hanging on the fork, and it passed all the way through, and it's still in one piece. Okay? So mine got all the way through. Okay, so your bottle, your vinegar, your funnel or some way to put the stuff in there, and your balloon. Now here's what we're going to do. We're going to put baking soda in the balloon, and, you know, probably mine is one of those round balloons like this. So I'm going to put baking soda in it up to where the balloon part starts, the round part starts. Okay? So I have my baking soda in my balloon. Everybody got their baking soda in their balloon? Okay, we'll wait a minute. Thank you, Jaegers. Okay, we're gonna pour vinegar into our bottle. About a quarter of the way up, maybe not quite. Now you're going to have to be careful when you attach your, okay, this is not my one, this is a demonstration. You're gonna have to be careful when you attach the balloon to the bottle, because you do not want your baking soda to fall into the bottle. Everybody understand me? You do not want the baking soda to fall into the bottle. So here's my real one. The green one is my real one. Green for 4-H. That's my real one. Okay? Now, what's going to happen when we mix the baking soda with the vinegar? We're fixing to make a what? Juliet, Wyatt, Joy, Larry?
I think it's gonna blow up. The balloon.
What's going to happen?
The balloon's gonna blow up. It's gonna blow up the
We're going to create a what? Vinegar and baking soda create what? A gas? That's right, it's going to make a gas. Okay? So when you, listen up everybody, or else you will have a mess. When you go to put your baking soda into your bottle, into the vinegar, hold on to the balloon at the mouth of the bottle. Hold on to the balloon, okay? And then hang on to it, don't let go. So when y'all are ready, you can go ahead and put your baking soda into your vinegar. What happened? Wow, look at all those balloons. Cool. Woohoo! So we created carbon dioxide, and carbon dioxide is what blew the balloons or expanded the balloons, right? Okay. How was that one? That's Miss Elena's favorite one.
Fun fact, the whole setup weighs the same before as it does after. The mass, the whole setup is the same before, and then when you mass it after, it's the same.
Say?
Yeah.
Say that once.
So a fun fact about this experiment is the mass of the bottle and the baking soda and the vinegar is the same as it was before. It's called conservation of mass.
Cool. Thank you, Miss Vicky. Can you think of another place we use carbon dioxide? Something that we use? What else where else do we like to have carbonation?
We can't hear you, Miss Starla. It's like almost like the microphone turned off. I know it didn't, but we just couldn't hear anything you just said. I no, I can read your lips, but no, ma'am, I can't hear you.
What about now?
A little bit better. You're definitely not as loud as you were, but you can hear. I can hear you better.
Okay, it's gotta be the microphone and the camera. Can you hear me or not, Rachel?
I can barely. It's almost like a whisper. I have it turned all the way up.
You're gonna have to unplug that microphone and turn the computer.
Yeah.
Let's see. Okay, Rachel, we changed modes of operation here. Can you hear me now?
Much better. Yes, ma'am.
Okay, all righty. Okay, so I asked you guys, after you did all of that, can you think of another place where we like to have carbonation? Sawyer?
Soda pop.
Very good, yes. In carbonated drinks. My husband would say soda water. Okay. Okay. You guys checked your ice cubes? Jaegers? And don't forget to stir your ice cream. Okay, can you still hear me?
Yes, ma'am.
Okay, all righty. So now we're going to move on to water and liquids. And we all know that water is a wonderful, wonderful thing. Can you live without it? No, that's right. You can go swimming, you can go playing in the water. Sometimes rain's not so much fun. If you live down here where I do, we get tired of the rain. It rained again today. We need it to drink. We also need it to grow our crops with, so we can have food. And water is a liquid, so it flows. All righty, can you name some other liquids? Who can name another liquid? Jaegers?
Juice.
Milk? Okay. Anybody else?
Lemonade and all kinds.
Okay. Then when we cool a liquid, what happens to it? Kira?
Yeah.
What happens to the liquid if we cool it? What happens to water if we make it really cold?
It freezes.
It freezes or turns to ice, and then it's a what?
Solid.
Solid. Very good, Nathan. So it can be a liquid, it can be a solid, and then if we boil it and it turns into steam or water vapor, what does it become then? Jaegers?
Gas.
Gas, right. So water can be liquid, solid, or gas. All right? And so that's really important for us to remember. Also, water has something called surface tension, and that's what holds it together, keeps it all together. So now,
Okay, now you need your pan. On your instructions, I said your cake pan 9x13. You need your little cards, and you need to draw your boat, whatever your boat's gonna look like. My boat looks like this. I don't know if you can see it or not. That's my boat. Jaegers, do you have a question? And we're going to pour water in our pond. This is my pond here. I don't know, I put maybe 1/4 of an inch, 1/2 inch of water in there, just enough so that the card can float on the water. You got your boat made? Not yet, Jaegers? Okay. Oh, very good, Juliet, Wyatt, Joy, and Larry. And I also forgot, you're gonna need your dishwashing liquid for this one. You'll need your dishwashing liquid. Are we getting there? Okay, whenever anything floats on the water, it's the surface tension that's keeping it afloat. The molecules in the water are very strong, and it's keeping everything together, kind of like a net or a web. And that's something we call surface tension. How are we doing with those boats? Okay, all y'all remember to help Mom clean up afterwards. I see Mom dragging all the kitchen stuff out. We got a boat? Yeah, Jaegers, how you doing on those boats? When you get your boats done, hold them up. Let me see them. Okay, Sawyer, be sure you can float your boat in your water. How about you? Oh, Jaegers, you're still working on yours? All right. Eleanor, Mikey, William, how y'all doing? Awesome. Juliet, Wyatt, Joy, and Larry, I know y'all are ready. Okie dokie, Sawyer, will it float? Okay, Jaegers are ready. Okay, so now just put your boat in your pond and just let it float there for a while. See how it just sits there? But it's floating. And I apologize, guys. The other camera, I don't have anymore because it died on me, I guess. Okay. So you can move your boat around with your finger and it just floats, right? Okay, so now move your boat back to one edge of your pond. Okay? And put a little bit of dishwashing liquid on the end of your finger. Everybody ready? Okay, we're still getting dishwashing, just a little bit. Don't take much. Okay. So now, make sure your boat's at one edge of the water, but you need enough space behind it that you can put your finger in the water. Okay, so now, touch your finger to the water and see what happens to your boat. What did your boat do?
It moved.
It moved? Cool. What happened was we broke the surface tension at the back of the boat with the dishwashing liquid, and then, so the surface tension in the front of the boat pulled it forward. Now, there's other things that can cause problems with the surface tension in water. And that would be stuff like pollution. So it would be oil slicks and all kinds of the pollution stuff that can get in the water. Now we have to think about the animals that live in the water and depend on that surface tension. And like if a duck lands in it, what's going to happen to the duck? Yeah, the duck's going to sink because the duck depends on the surface tension to provide it with part of its buoyancy in the water. Okay, so it becomes really important that we pay attention to pollution. Questions? I think y'all are having way too much fun with that one. Did you enjoy that one? Cool. Okay. All righty, we're going to do one more, and this is going to be the last one we're going to do, okay? Okay, this is the one we call to see how things float or sink. So I'm using a pint jar. Okay, like I said in the instructions, if you use a pint jar, then you need about a half a cup of each. So I've already put my syrup in here. So you need to put a half a cup of syrup in your pint jar. You got your syrup in your jar? Huh? They had a surprise. Half a cup of syrup in the pint jar. Then you're going to need a half a cup of cooking oil. A half a cup of cooking oil. And you're going to pour that in on top of the syrup in your pint jar. From the top, sweetie, so you can see the layers. No, yeah, move your hand. There you go. See how the oil sits on top of the syrup? Okay, so the liquids did not mix. Then we need a half a cup of colored water. And you're going to pour that in on top of the oil. And then I want you to tell me what happened. Jaegers?
It got,
What happened?
it went, it went under the back. It stayed
It
above the syrup,
went-
but went
You're right. It didn't float on top of the oil, did it?
slow.
Okay. So which one was heavier, the oil or the water? Jaegers?
Water.
Right. But the heaviest is what? Yes? Jaegers?
The syrup.
Very good. I don't know if we can see it. I don't know that we can hold it. Oh yeah, that's good. So the oil is on top, my water was green, and then my syrup. Now, you guys were told to gather up. You guys were told to gather up some stuff to see where it would stop or float, right? So, in my little bag, I have some noodles, just little pasta noodles. I have a nickel and a penny. I have a washer and a nut. And I have a screw. Also, I brought from home, I have a couple of tomatoes, little grape tomatoes, and then I have a couple of grapes, a red one and a green one. So now you need to ask the question before you drop it in, where do you think they're gonna stop? Where are they gonna float? What about my noodles? Where do you think they're gonna float? That was a heavy noodle. It went all the way to the syrup. It's floating about midway of the syrup. Okay? So where do y'all think my tomato's gonna stop? Oh, the tomato's floating on top of the syrup. Keep it up. What do you think is going to happen to my nickel? Where'd it go? Went all the way to the bottom. It went all the way to the bottom. So now you can play with this. Let's see. I have the little red grape. Let's use the green grape. We'll use the green grape and see where it goes. It's sitting right on top of the right on top of the syrup. Give it job too to make a difference. This all depends on density, the density of the fluid, the liquid, okay? The denser the liquid, the harder it is for those objects to fall through. It doesn't necessarily have to do with size, it's just how tightly it's put together, okay? So it's something that we call density. So something with a lower density would weigh less, okay? And that's what we're showing here. Are there any questions? All right, let's look at our ice cream and see where we're at with our ice cream. My ice cream's almost frozen. Here's a chunk of ice, or ice. It's just like ice cream. Okay? Huh? Yes, you can eat it. Remember, it was milk cream and chocolate milk, chocolate powder. So yes, you can eat it. I practiced this last night on my husband, and this was my dessert last night. He thought it was pretty good. Oh, I didn't send you. I didn't send you the survey. Yeah. What do y'all think? think? Was it any good? I don't know about y'all, but I like chocolate ice cream. Mine's pretty good. Okay, does anybody have any questions? Well, I want to say thank you to all of you for participating in our summer camps. I know that y'all have 2 more.
Miss Starla,
Yes, ma'am.
we're also going to be putting a survey in the chat box.
Yes, ma'am. I was going to talk about that. I want to thank you for being on our summer camps. I know there's 1 more tomorrow and 1 more on Thursday. That's very exciting. And we've enjoyed doing this. And all of those surveys that y'all have been doing, we really do appreciate your feedback. We really want to know everything that we need to do differently or that you enjoyed that we did this. Okay? Miss Christie has put the survey in the chat. So you guys all know that you can click on it right now and go ahead and answer the survey, and then it'll be done. So, but the survey is in the chat. And like I said, y'all don't forget to help Mom clean up because she'll love me about right now.